Today we are starting the third chapter, Counting Principles, in which we will study different counting principles which will help us to solve problems based on finding the number of ways of doing certain tasks. Okay, and here we will make use of cardinality of the set. The approach is the approach towards counting will be based on the cardinality. Okay, so what comes in your mind when you hear this word counting? Anyone?
Numbers.
Numbers. And how do you count? How do you count?
By adding.
Now, how do you start counting? Tell me, you want to count something. You want to count how many books are there in your at your home? Any kind of books, all the books you want to count. So how will you start counting?
Taking them individually and putting them
That
together.
means you will use these numbers, no? 1, 2, 3, and so on.
Yes.
So do you start counting from 0?
No.
Do you start counting from -3, -2,
No,
-1?
ma'am.
Not at all, right?
No.
You always start counting from 1. This you understand? Okay. Because we use natural numbers for counting, right? We don't say that we have -3 books at home. Do you say like that?
No, ma'am.
Never.
No, ma'am.
So basically we want to see now what is cardinality of a finite set. Okay, so when I say that number of books at your place, so you will have a finite number, right? Somebody will have 50 books, somebody may have 100 books, but will you say that I have infinitely many books, ma'am, at my place? Will you say that? No, right? So we want to first see what is a finite set. Finite set means it has finite number of elements. Okay, somewhere that set is going to end. Okay, you have studied these concepts: countably finite, countably infinite. You have studied countably infinite numbers of sets. Countably infinite sets you don't know. You can count.
Yes, we know means we know the meaning.
Countably infinite, the set of integers. This natural number set, this is infinite, no? It goes on and on and on.
Yes.
But you can count it. You can count the numbers 1, 2, 3, 4, 5, 6, 7, right? This is countably infinite. There are uncountable sets also. Can you count stars?
No.
You can count them, no? 1, 2, 3 ऐसे बोल सकते हो. But that is infinite set.
But they are infinite.
They are infinite in number, right? You don't know where it will turn up, right? So that is countably infinite set. So we will consider a finite set. Do you understand the meaning of a finite set now?
Yes.
Finite set means a set which has finite number of elements. For example, set of your friends. Do you have infinitely many friends? Does anybody have infinitely many friends? You have, ultimately you will stop somewhere, right? Somebody may have 100 friends, 200, 1000 friends. Somebody will be so friendly, right? Even you are on social media site, Facebook. How many friends you have?
4,000.
4,000. But that is a finite number, no? You know the number.
Yes.
So set of your friends is finite set. Then number of fingers you have. Hmm? Then anything. Set of alphabets. Set of alphabets.
Set of subjects in first year.
Yeah, very good. Set of subjects in the first year. Very good. So this is finite set. Okay. So what is the cardinality of this set? Hmm? So cardinality of a set, first of all, we will define. This is a new thing to you, is it?
Yes.
Cardinality, you have not heard this word before, cardinality. Please write it down side by side. Let A be a finite set. Okay, so we are going to consider finite sets. Therefore, you must know what is a finite set. Let A be a finite set. The number of elements in A is called cardinality of A, and it is denoted by mod A or cardinality of A. But usually we will use this mod A thing, okay? We will make use of this notation usually. So in mathematics or in real life, there are various problems where you want to find out the number. In how many ways you can do this, in how many ways you can do that. So for that, if you actually start counting, that can become a tedious job. Instead of that, if you use certain principles, certain formulae, then it becomes an easy task. Okay, and therefore we study counting principles. There are various nice counting principles in maths where you need to use cardinality. Tell me as you finish writing this. Finish writing.
Yes, ma'am.
Yes, ma'am.
Hmm. So we suppose I write a set now. Hmm. Let A be the set of, I will say the set, alphabets in the word dear. Okay. Therefore, what will be A? A you will write as DEAR, right? Repeated elements you don't take, right? All alphabets here are distinct. You can use small letters also, doesn't matter. You have to take every element only once, though it appears twice, thrice, etc. Okay, so this is first element, right? This is second element. This is third
Yes.
element, and this is fourth element. So there is a mapping between the elements of A and the set of natural numbers 1, 2, 3, 4. Are you getting? Cardinality is nothing but mapping. between the given set and the set of natural numbers. ये फर्स्ट एलिमेंट है, ये सेकेंड है, ये थर्ड है, ये फोर्थ है, ऐसे हम काउंट करते हैं. ओके, so what is cardinality of A? It is 4. There are 4 letters, there are 4 alphabets, right? Are you getting it?
Yes.
So
Yes, ma'am.
there exists one-to-one correspondence between A and N, any set of natural numbers. Okay, as we count 1, 2, 3, 4 onwards, set of natural numbers आप ऐसे लिखते हो 1, 2, 3, 4. So there is one-to-one correspondence. Now I am considering another set. Let B be the set of elements, set of alphabets. Each member of the set is called as an element. Okay, do you know this word element?
Yes.
Huh. Let B be the set of alphabets in the word read. So what will be B? B will be equal to R E A
E.
D, right? So what is
Yes.
cardinality of B? Again,
4.
has 4 elements, so its cardinality is 4. Now see the elements of A carefully and see the elements of B. What do you find?
Same. Same.
Same elements you are getting. The order doesn't matter in set. Huh? Order absolutely doesn't matter. Hmm? So can you say A is equal to B?
Yes.
Yes. The sets are equal because they contain the same elements. As they contain the same
Yes.
elements, their cardinalities are also same. If the sets are equal, the cardinalities are also same.
Yes. Yes. Same.
Sets are equal and you are writing cardinalities are different, then that is a contradiction. Okay, observe that A is equal to B and cardinality of A is also equal to cardinality of B. So please remember, these are the basics of set. That in set you do not repeat any element. You write the element only once. You separate the elements by a comma, and you can write them in any order. Order is not important in the set. Finished writing? Finished writing?
Yes, ma'am. Yes, ma'am.
So we saw when the two sets are equal. Now we will see a special set, an empty set. Okay, empty set. Phi. What is the name? Phi. This is called as phi.
5.
Yeah. So if A is an empty set means no elements. No elements. Okay, then obviously cardinality of A becomes 0. Okay, cardinality of phi is cardinality of A is 0. Okay, now we want to see basics of counting. Okay, under that the first one we are going to see is the rule of addition, or you can simply call it as addition principle. Okay, so let us consider two sets now. Let A be equal to A, C, E. Okay, and B is another set, B, D, F, G. Okay, so do you find anything common in these two sets?
No. No. No,
So
ma'am.
such sets are called as what?
Disjoint.
Disjoint. A and B do not have any element in common, right? Therefore, A and B are disjoint sets. Everybody is following this? That is, their intersection is phi, correct? When the two sets are disjoint, they do not have anything in common. You know what union and intersection, right?
Yes, ma'am.
So what will be A union B then? A union B क्या होगा?
All the all the
All
elements.
its elements, right? That means I have A, C, E in A and B में क्या था? B, D, F, G. Okay. Now let us come to the cardinalities. What is cardinality of A? There are three elements in A, right? What is cardinality of B?
Yes.
Yes, ma'am. 4.
4. Cardinality
Four.
of B is 4. And what is cardinality of A union B? How many elements are in
7.
there? There in A union
7.
7. So do you find that 7 is equal to 3 plus 4?
Yes.
So cardinality of A union B is equal to cardinality of A plus cardinality of B.
Yes.
And this is called as addition principle. But what is important here? A intersection B should be phi. There should not be anything in common. Okay. We will take another set C suppose. C में लेती हूँ PQRS. आपका A था ACE, B था BDFG, and now I'm taking C. So do you find anything in common in any two sets? What is A intersection B? It is already 5 we have seen. What is B intersection C? Anything in common between B and C?
5.
No, ma'am.
B and C में भी कोई कॉमन नहीं एलिमेंट्स. ओके. A and C में कोई कॉमन है?
No.
No.
So these are pairwise disjoint sets, right? Pairwise disjoint. A, B, C are pairwise disjoint sets. समझा क्या? Mutually disjoint कहते हैं इसे या pairwise, okay? And of course, if they are pairwise disjoint, तो इन तीनों में एक साथ कुछ कॉमन होगा क्या?
No.
That is also fine. Now what will be A
Yes.
union B union C?
All the elements.
All the elements. So I am specifically writing in order, हाँ, कि A के पहले ले लूँ फिर B के, ताकि आपको पता चले. Now what is cardinality of A union B union C?
Cardinality of A plus B plus C.
11, right? It is 11.
हाँ.
And what is cardinality of
हाँ
A?
हाँ.
Cardinality of A is 3, cardinality of B is 4, cardinality of C is also 4. So cardinality of A union B union C is equal to cardinality A plus cardinality B plus cardinality C. Okay, this is called as addition principle. So this I showed for 2 sets. Okay, this is for 3 sets. This is called as addition principle. So you can extend the same idea to any number of sets, right?
Yes.
So we actually want to prove this as a theorem. Okay, so for today you just write the statement. Have you finished writing this?
No, no.
So next 2 chapters are big. Huh? This counting principles and recurrence relations is also a very big chapter. So you have to take these chapters very
Ma'am,
well.
can you scroll up once?
This one you want?
Previous slide.
Because all of you must write this. Do not be lazy because you don't have textbooks right now. Correct? So your notebook should become a very good textbook itself. And later on it will be very difficult for you to read and write. Okay? So don't be lazy. In the lecture itself, you write down whatever I am dictating. Finished?
Yes, done. Yes.
Okay. Now let us state the addition principle. Okay, this is theorem number 1, addition principle. So we need to actually prove this theorem. Okay, this is what it is happening, we have seen, but we need to prove it mathematically. Let A and B be two disjoint and finite sets. Two disjoint and finite sets. So these words are very important here. Okay, disjoint and finite. Disjoint means they do not have anything in common, and finite means they contain finite number of elements.
Countable.
Yeah. Not countable only, they are finite. Of course, they are countable. Let cardinality of A be equal to n and cardinality of B equal to m, then cardinality of A union B is equal to n plus m. This is what we want to prove. Okay.
Yes.
So we will prove this tomorrow. Right now it is the time for attendance. We are meeting tomorrow at 8 o'clock for the sanctuary. Okay.